Hello guys and welcome to Studsbox. So today we'll be discussing about Kepler's law of planetary motion. So Kepler gave three laws. First is law of orbits. Second is law of areas, and the third is law of periods. So these are the three laws we are going to discuss today. So first of all, taking first law, that is law of orbits. So Kepler described this law as that all planets moves on elliptical orbits with Sun at one of its foci. Here foci means focus only, it is the plural form of focus. So an ellipse looked something like this. So this is an ellipse. So according to definition, all planet moves on elliptical orbit. So all planets move on this elliptical orbit with Sun at one of its foci. So either Sun is at this place or Sun is at this place. This is Sun. So let's divide this into four halves. This and this. Let's call it O. This is B, this is C, and let's take it P and A. Okay, so let's currently take that Sun is at this point. So if Sun is at this point, this P point is called perihelion. Helion is for Sun and peri is for close, so it means closest point to the Sun. Okay, and if the Sun is at this position and this is the farthest point A, so A is called aphelion and this is farthest point to the Sun. So it's pretty confusing that which is the farthest point and which is the closest point. What do we call it, aphelion or perihelion? So here's a shortcut way, that is mnemonic. We can use a mnemonic. If you don't know what a mnemonic is, basically a mnemonic is a shortcut way to learn something. So we can take here, so point near, and I could say, I will take a black pen here, Sun. Point near Sun, and here is farther point, and we have two things. One is aphelion and one is perihelion. That is aphelion and other is perihelion. So if you check in the dictionary or if we check in alphabetical order, so what is the closest alphabet to S? Is it A or P? So it is P. So P, this perihelion, is near to Sun, and the farthest point from S is A, so aphelion is the farthest point from the Sun. So this is a way, this is a mnemonic to memorize it. Okay, so now let's take this AP. So half of this line AP is called semi major axis, that is here, as you can see, this is AO and this is PO. So AO equals to PO equals to semi major axis. So this was our first law of orbits. Now talking of Kepler's second law, that is law of areas. So the line, according to this law of areas, the line that joins Sun and the planet, the line that joins Sun and the planet sweeps out equal distances in equal amount of time. So what does this mean? So let's take a figure. This is an elliptical orbit with Sun at one of its foci. So this is Sun. Let's take these are 2 points AB, and these are 2 points C and D. So according to this law, if a planet is at point B and takes time delta t to reach point A, and other planet is at point D and also takes delta t time to reach C, then area, that is, if we take this as S, this point as S, then CDS, area of CDS equals to area of SAB. So what this law basically say is that aerial velocity of planet remains constant. So from the figure you can guess out that a planet in time delta t that is far from Sun moves only a small distance AB, whereas a planet D that is near Sun moves a larger distance CD in that same time interval delta t. So what we get now is that a planet far from Sun is moving slower, and a planet near Sun moves faster. So delta A is equals to delta A by delta t is constant, that is aerial velocity of planet remains constant. So what is aerial velocity? Aerial velocity is nothing but area swept out by the planet in a time delta t, that is delta A by delta t remains constant. So if you see this figure carefully, you will notice that here planet conserves its angular momentum. So let's talk about one proof of this statement. So if we take this distance to be r, and the change in time delta t is delta r, so this will be r plus delta r. So area swept out by the planet will be area swept out by the planet, that is delta A by delta A will be equals to half of, if we take this is a triangle and this is the height, so it will be half of r into delta r. Okay, so dividing both sides by delta t, dividing both sides by delta t, it will become delta A by delta t is equals to half into r into delta r by delta t. Okay, so if I say that delta t is tending to 0, that is delta t is a very small time, so this whole equation will become dA by dt is equals to half of r into dr by dt. And we know differentiation of radius, differentiation of a distance is equals to speed. So because we know v equals to dr by dt, we also know that distance equals to speed into time. This will imply as speed will be equals to distance by time, and same is happening here, dr by dt. So instead of this dr by dt, dA by dt equals to half, instead of this dr by dt we can write v, so it is half r cross v. we know momentum is equals to mv, so v will equals to p by m. So now using this in this equation we will get dA by dt will be equals to half cross r into p by m. Okay, solving this further, dA by dt is equals to 1 by 2m into r cross p, and we know r cross p is equals to angular momentum. So simplifying this, we can write dA by dt equals to L by 2m. So as you can see here, m is constant, mass never changes, and the angular momentum, that is L, is also constant as we have discussed previously. So if this is constant, that is if L by 2m is constant, then it is obvious then dA by dt is also constant. So this is the proof of dA by dt to be constant. Now coming to our third law, that is law of periods. According to this law, square of time period of revolution of planet is proportional to cube of semi-major axis of the ellipse traced out by the planet. To understand this, we can draw the same diagram of the ellipse. This is the ellipse. This is the sun at one of its foci. This is BC, and this is A, this is P. Okay, so let's take semi-major axis is equals to A. This is O. So semi-major axis is equals to OA equals to OP equals to A. So according to the definition, T square is time period of revolution of planet under which it traces out a distance of semi-major axis, that is A. So T square is directly proportional to A cube. So square of time period of revolution of planet. So this whole revolution, square of this time period, and cube of this semi-major axis. So these are proportional to each other. To equate this, we will use a constant that in this case will be Q. So this was law of period.